Big concerns this morning in Florida, where a massive sinkhole opened up, draining radioactive water into an underground water source.
Beneath the waters off the coast of Florida, the ocean floor has given way in a dramatic and unsettling display of geological instability. Vast sections of the seabed have collapsed, plunging downward and leaving behind sudden yawning sinkholes that swallow everything in their path. These oceanic sinkholes, appearing in clusters across different parts of the continental shelf, are not just physical scars on the seafloor but profound reminders of the dynamic and fragile balance that governs Earth's geology. For decades, scientists have understood that Florida rests on a porous foundation of limestone and carbonate rock, but no one anticipated the abruptness or the sheer scale of the collapse now unfolding beneath the waves. Before we start, smash the like and subscribe buttons for more updates. The surface world remains largely unaware of the violence taking place below, but in the silent depths the consequences are immediate. As the seabed caves in, sediment plumes burst upward, spreading clouds of fine particles that drift like underwater storms. Fish scatter in confusion, coral heads crack and topple, and the carefully woven tapestry of marine ecosystems is torn apart in seconds. These sinkholes are not shallow depressions, but immense cavities plunging hundreds of feet down into darkness. They are gateways into the hidden architecture of the Earth, passages into aquifers and voids long sealed from light, suddenly exposed by the collapse of the ocean floor. Florida's coastline has always been shaped by the interplay of water and rock. The state sits atop karst terrain, where underground rivers carve out caverns in limestone, leaving the land above vulnerable to sudden collapse. On land, this has meant sinkholes swallowing homes, roads, and entire neighborhoods. But now, with similar processes reaching into the ocean, the stage shifts to a far larger scale. Salt water seeps into weak layers of carbonate rock, eating away at their integrity until the roof of these subterranean chambers finally gives way. The difference beneath the ocean is the weight of the sea pressing down. When the collapse happens, the implosion is violent and expansive, creating a cascading effect that can destabilize miles of seafloor in a single event. Marine scientists surveying the area describe the seafloor as a patchwork quilt suddenly unraveling. Where once there were fields of seagrass, coral mounds, and sandy plains, there are now gaping holes rimmed with fractured rock and tumbling slopes of debris. Each new sinkhole seems to destabilize its neighbors, setting off a chain reaction that spreads outward. The sinkholes vary in size, some no larger than a suburban swimming pool, others vast enough to swallow entire city blocks if they existed on land. What unnerves researchers most is not only their scale, but the speed with which they are appearing. These are not slow erosional features developing over centuries, but sudden collapses occurring in hours or days. The implications for Florida's marine ecosystems are profound. Coral reefs, already stressed by warming seas and acidification, now face the additional threat of physical collapse. Sponges, mollusks, and reef fish lose their habitats in an instant as entire structures vanish into these holes. The sediment clouds raised by the collapse smother nearby organisms, cutting off sunlight and suffocating delicate filter feeders. The intricate web of marine life, built up over thousands of years, is being shredded by geological upheaval in the span of a season. For Florida, a state whose economy and culture are tied to its coastal waters, this is not only a natural phenomenon, but a seismic shift with far-reaching consequences. Beyond ecology, the collapse of the seafloor poses risks to the physical stability of the coastline itself. The continental shelf acts as a foundation, a submerged extension of land that disperses wave energy before it reaches the shore. As sections of the shelf collapse, that protective buffer weakens. Waves may travel farther and with more force, amplifying erosion along beaches already battling rising seas. Florida's famed stretches of white sand from Miami to the Panhandle could find themselves under siege from intensified coastal processes fueled not only by climate change, but by the very ground beneath the ocean giving way. The sinkholes also expose Florida's complex network of aquifers to the open sea. These underground reservoirs, once shielded by layers of rock, may now lie vulnerable to saltwater intrusion. Freshwater resources already strained by population growth could face contamination as ocean water pushes inland through collapsed conduits. For a state dependent on aquifers for drinking water and agriculture, the intersection of geology and hydrology becomes a looming concern. The collapse of the ocean floor does not remain confined to the deep. It reverberates upward into the daily life of millions of Floridians. Geologists studying the event emphasize that this collapse is not isolated. It is part of a larger pattern of instability inherent to karst landscapes. Florida's limestone base is riddled with voids, caves, and fractures carved by millennia of water flow. On land, heavy rains, groundwater extraction, and construction can trigger sinkholes. Underwater, the drivers are subtler but equally powerful. Changes in sea level, shifts in pressure, and the steady dissolving action of salt water on carbonate rock. These forces have always been present. But now, in combination with human influence and a changing climate, they converge to accelerate processes that might otherwise have unfolded invisibly over centuries. For divers and researchers, approaching these sinkholes is both exhilarating and terrifying. Descending into the darkness of a fresh collapse feels like entering another world. The walls are jagged and unstable, pieces still tumbling inward as gravity claims its due. Strange creatures emerge from the depths, species long trapped in subterranean aquifers suddenly released into the open ocean. Biologists seize the chance to study these accidental revelations, knowing that life hidden from the surface for millennia is being exposed. Yet each dive carries danger, for the ground is still shifting and the voids are unpredictable. The suddenness of these events sparks questions about broader seismic or tectonic influences. Florida is not known for earthquakes, but the collapse of large voids beneath the seafloor can mimic seismic tremors, sending ripples outward that instruments register on shore. The line between a geological collapse and a quake begins to blur, leaving scientists to reassess the forces shaping the region. Could Florida's foundation, long thought to be relatively stable, be more fragile than assumed? The sinkhole suggests that the answers may be unsettling. Shipping routes, offshore drilling platforms, and undersea cables are also drawn into the sphere of risk. The Gulf of Mexico and Atlantic approaches to Florida are busy with commercial activity, and sudden collapses beneath the seafloor threaten infrastructure that lies unseen but vital to global trade and communication. A cable severed by a sinkhole could cut digital lifelines, while a drilling rig destabilized by shifting ground could trigger environmental disaster. The ocean floor, once thought to be a steady stage for human activity, reveals itself as a restless and unpredictable terrain. Communities along Florida's coast watch with unease as reports filter back from marine surveys. For now, the sinkholes remain offshore and beneath the waves, but the interconnectedness of geology means their effects do not stay hidden. Each collapse alters water currents, sediment transport, and coastal resilience in ways that inevitably touch human settlements. The ocean's floor is collapsing not in isolation, but as part of a chain of cause and effect that binds ecosystems, infrastructure, and people together. The gulf between natural event and human consequence narrows with every new sinkhole. As researchers continue to chart the unfolding collapse, one theme emerges: unpredictability. Sinkholes form without warning, expanding faster than models can predict. Technology struggles to keep pace with the raw forces at work in the depths. Sonar imaging reveals new voids forming even as old ones collapse. What is happening off Florida's coast is a reminder of nature's capacity to surprise, to shatter assumptions about stability, and to demand humility from those who study it. The ocean floor is not a static landscape, but a living, shifting system where collapse can come without a moment's notice. For Florida, the collapse of the ocean floor is both a geological drama and a profound lesson. Beneath the beauty of turquoise waters and sandy beaches lies a complex and fragile foundation. Limestone dissolves, voids form, and the balance between water and rock is never permanent. The sudden appearance of massive sinkholes is a reminder that the ground, whether beneath land or sea, is not as solid as it seems. It is an arena of constant change where collapse and renewal shape the world in cycles measured in both moments and millennia. As scientists, engineers, and communities grapple with the implications, the event off Florida's coast becomes a defining chapter in the story of human interaction with the planet. It is a story not of aftermath or recovery, but of confrontation with forces larger than ourselves. The ocean floor has collapsed. Sinkholes gape where once there was solid ground, and the message is clear. The earth beneath the sea is as alive and volatile as the storms that rage above. The collapse of Florida's ocean floor into sudden sinkholes has unleashed a cascade of consequences that ripple outward in ways not always immediately visible. When sections of the seafloor fall inward, The most obvious feature is the gaping void itself, but the event is far more than just a hole in the earth. Each collapse alters circulation patterns, redirects currents, and reshapes the entire physical geography of the surrounding environment. In a region where water movement dictates life, erosion, and coastal health, even small changes in flow can have vast repercussions. The ocean is a constantly moving system, and sudden geological transformations insert new variables into its rhythms. Channels that once carried nutrient-rich upwellings may be cut off, while new depressions draw water downward, creating eddies that disorient marine life and transport sediments into unfamiliar places. Oceanographers are beginning to study how these sinkholes modify the Gulf Stream and smaller coastal currents that sweep along Florida's shoreline. The Gulf Stream, one of the most influential currents in the world, depends on the balance of heat, salinity, and seafloor topography. When large portions of the ocean floor collapse, that balance is subtly altered. Water no longer encounters the same slope or resistance, and in certain places, the course of currents bends in unexpected ways. A current pushed just a few degrees differently near Florida can affect weather patterns across the Atlantic, shifting storm tracks and rainfall patterns that extend as far as Europe and Africa. The sinkholes, therefore, are not merely local features but disturbances with the potential to echo across hemispheres. In the immediate environment, the collapse creates zones of instability where water behaves chaotically. Deep sinkholes suck in colder, denser water from above and release it outward in unpredictable jets. Fish, accustomed to steady conditions, are caught in strange whirlpools and surges, while plankton blooms may be disrupted by sudden vertical mixing. For predators that rely on predictable hunting grounds, this shift is disorienting, forcing them to seek food elsewhere. Schools of fish abandon traditional routes, cascading effects up the food chain to dolphins, sharks, and seabirds. The collapse is not just a geological occurrence. It is the tearing apart of ecological maps that marine life has followed for generations. Beyond ecology, the sinkholes expose something more mysterious: the subterranean architecture of Florida's aquifers and ancient caverns. Many of these cavities formed tens of thousands of years ago when sea levels were much lower and Florida's limestone bedrock was exposed to surface erosion. Over time, as the ocean rose, these caverns filled with water and were sealed beneath layers of sediment. The sudden collapses act as ruptures in geological time, reopening doorways into prehistoric spaces. Within them lie fossils, mineral formations, and perhaps even unique microbial life that has been isolated from the surface world for millennia. Each collapse is like opening a forgotten chapter of Earth's geological record, an unintentional excavation into archives carved by ancient waters. For scientists, these newly revealed spaces offer a tantalizing chance to understand Earth's history. They can study the mineral deposits lining cavern walls to reconstruct ancient climates, examining chemical signatures locked within rock. The fossils that tumble out with collapsing sediment may include species long vanished, remnants of Pleistocene ecosystems preserved beneath the seabed. Microbiologists are particularly fascinated, as these environments could harbor extremophiles, organisms adapted to complete darkness, high pressure, and mineral-rich water. Such discoveries could reshape understanding of how life adapts in extreme environments, and even inform the search for life on other planets, where subsurface oceans may shelter organisms beneath icy crusts. As awe-inspiring as these discoveries might be, they come with equal danger. The sinkholes are unstable and prone to further collapse, making exploration treacherous. Underwater vehicles risk being swallowed by tumbling debris, and the delicate sediments that record Earth's past can be destroyed by even the smallest disturbance. Human curiosity collides with natural volatility, creating a race against time to document and preserve what can be studied before it is lost to further collapses. Each expedition must balance scientific ambition with the knowledge that the very act of exploration may destabilize an already fragile system. On the surface, Floridians are beginning to contemplate the cultural and symbolic meaning of the ocean floor collapsing so dramatically. The sea has always been both a source of livelihood and a threat. From hurricanes to red tide blooms, the waters around Florida have long been both beautiful and dangerous. But the idea that the ground beneath the ocean could suddenly disappear is a new kind of unease. It challenges assumptions about permanence, forcing people to question the reliability of the very earth underfoot, or undersea. Coastal residents already live with the awareness of rising seas and intensifying storms. Now they must add collapsing geology to the list of risks that shadow their horizon. The collapse also resonates with deeper fears about humanity's relationship with the planet. The idea of sinkholes swallowing land or sea conjures images of instability, of a world no longer holding steady. It plays into collective anxieties about environmental fragility and the consequences of pushing natural systems beyond their limits. Whether or not climate change is a direct trigger, the collapse fits into a larger narrative of disruption. Ice sheets breaking, forests burning, and now the ocean floor itself tearing open. Each event becomes a reminder that Earth is not static but alive with processes that dwarf human control. Economically, the implications cannot be overstated. Florida's economy thrives on tourism, fishing, and real estate, all tied intimately to the coast. Tourists flock for coral reefs, clear waters, and marine life encounters. Yet, as sinkholes disrupt habitats and cloud waters with sediment, the appeal of these underwater attractions diminishes. Dive sites vanish overnight, replaced by unstable voids unsafe for exploration. Fishing grounds are thrown into turmoil as species abandon altered habitats, leaving boats to chase dwindling catches. Even the perception of danger, headlines proclaiming collapsed ocean floors and gaping sinkholes offshore, can dampen tourism, regardless of whether the events pose direct risk to visitors. Property markets too feel the tremors of these geological changes. Coastal real estate already faces scrutiny due to rising seas and flood insurance crises. The knowledge that the seabed itself is collapsing adds a new layer of uncertainty. If the continental shelf is destabilizing, how secure is the shoreline it supports? Beaches eroding faster than predicted could undermine billion-dollar properties, shifting the economic calculus for homeowners and investors. The collapse of the ocean floor thus reverberates into boardrooms, policy debates, and insurance models, shaping financial decisions as much as geological ones. For policymakers, the sinkholes demand urgent consideration of resilience strategies. Coastal defenses are typically designed with storms, tides, and erosion in mind. Few plans account for the sudden collapse of the seabed. Engineers must rethink how to design seawalls, jetties, and infrastructure when the foundation beneath the ocean itself is unstable. Questions arise about offshore drilling safety, pipeline routes, and shipping channels. The sinkholes turn the seabed from a presumed constant into a variable, complicating every calculation for development and defense. The collapse also raises broader questions about humanity's role in triggering or accelerating natural processes. While sinkholes are inherent to karst geology, human activity amplifies vulnerabilities. Groundwater extraction, urban development, and alterations to hydrology can weaken rock formations. Offshore drilling, dredging, and other interventions disturb the seabed in ways that may exacerbate collapse. Climate-driven sea level rise increases pressure on underlying voids. It is possible that what is happening off Florida is not simply a natural cycle, but a convergence of natural processes and human influence. If so, the sinkholes are not just geological curiosities, but warnings of how intertwined human actions are with Earth's most fundamental systems. From a psychological perspective, the collapse of the ocean floor confronts people with the unsettling reality of hidden instability. Unlike storms or visible erosion, sinkholes represent danger lurking unseen beneath the surface. They appear without warning, tearing away ground that seems solid. This unpredictability unsettles human confidence in control, tapping into a primal fear of being swallowed whole by the earth. As news spreads, the imagery of collapsed seafloors feeds imagination and dread alike, becoming a potent symbol in cultural narratives about fragility and change. The event also forces a reconsideration of how humans map and monitor the oceans. For all the satellites orbiting Earth and sensors probing its surface, vast stretches of the seafloor remain unmapped in detail. The collapse in Florida exposes how little is known about the structures beneath the waves. If massive sinkholes can appear suddenly, how many other regions of instability lie undetected along coastlines worldwide? The call for more comprehensive mapping grows louder, demanding investment in sonar surveys, autonomous underwater vehicles, and data networks capable of detecting subtle shifts before they cascade into collapse. In a broader planetary sense, Florida's collapsing seabed becomes a case study for global geological vulnerability. Karst terrain underlies many regions of the world, from the Mediterranean to Southeast Asia. Coastal populations everywhere rely on the assumption that the ground beneath the ocean is firm, yet Florida shows how quickly that assumption can crumble. What happens here could be echoed elsewhere, making the event a warning not just for one state, but for all regions perched on fragile limestone foundations. The interconnectedness of Earth's systems means local collapse holds global lessons. As sinkholes multiply, artists, writers, and storytellers also turn their attention to the phenomenon. The image of the sea swallowing itself resonates with themes of disappearance and transformation. It becomes metaphor as much as geology, inspiring works that grapple with instability, loss, and the unpredictability of nature. In this way, the collapse enters not only the scientific and political discourse, but the cultural imagination, shaping how society interprets its relationship with the planet. The ocean floor's collapse is a geological fact, but it is also a symbol that speaks to deeper currents of meaning. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Florida's ocean floor collapse and sudden sinkholes forming? We want to hear from you. Thank you for watching, and see you next time.